This is another problem on a standard coordinate plane where now I'm being asked for double angle values, double angle trig expressions, given a little information about the angle in question. In this case, it's beta. Okay, so I've got angle beta such that cosine of beta is 1/6 and the secant of beta is negative. And using that information, I should be able to figure out all the rest of this based on my understanding of the unit circle and some trig identities and basic fraction operations. So you remember the double angle identities. Hopefully you've memorized these. If not, you know how to make them over again using the summation angles. And I want to focus on this guy first. 2 sine A times cosine A. Okay, that's going to tell us sine of 2 beta right there. So we're going to say, let me just write that over here. Sine of 2 beta equals 2 times sine of beta cosine of beta. Okay, so it's very clear that we need to know sine of beta and cosine of beta. We don't know those. We do know cotangent of beta, and I think we can figure out sine and cosine given cotangent and a little bit more. If you think about the unit circle, right, it always comes back to this. There it is. If you think about the unit circle, where's cotangent positive? Remember what I have here? Cotangent beta equals 1/6. And if I remember, it was secant negative. Okay, secant beta is less than 0. Now, where are some things we're familiar with? Maybe. Flip cotangent over. That means tangent is equal to 6, according to the quotient identity. And secant of beta, according to the reciprocal identity, if that's negative, that means cosine is also negative, right? Remember, there are some very important things I'm assuming you know here. One is that tangent equals 1 over cotangent. And the other thing I'm assuming you know is cosine equals 1 over secant. And there's all sorts of ways of saying those ideas. Now, if tangent is 6 and cotangent is negative, cosine is negative, where are we here? Well, if you look in quadrant 2, that is where you have negative cosine, but you also have negative tangent. So that's no good. I need positive tangents. Well, fine. Squiggle, squiggle, squiggle. Let's erase that. Let's talk about quadrant 3. In quadrant 3, I have cosine less than 0, and I have tangent greater than 0, and that is what I want. Okay, so I know we're in quadrant 3. This is a big victory. Now we can go draw a triangle. Okay, so let's just draw a triangle right here. It's a quadrant 3 triangle, which means it's going to look something like this. I don't know exactly, but let's see. This is beta right here. That's my angle beta, which means I can now put some sides on this. Cotangent, if you remember, is adjacent over opposite. Okay, this little SOHCAHTOA there. Now, if cotangent is adjacent over opposite, and that is equal to 1/6, let's just put some sides on this triangle. So adjacent is 1, and opposite is 6. Well, that's great. There's a little something wrong here, and you might be able to see it. Remember, we're going into quadrant 3. That means negative values on the x and y axes. Does this still make sense that cotangent is 1/6? Well, I think so, because this is now negative 1 over negative 6, and that is the same thing. That is 1/6. Okay? So we need to find the hypotenuse of this triangle that I drew in quadrant 3, and that is going to be, square root of 37, according to the Pythagorean theorem. And now I can finally say what is sine and cosine. That was my goal, or at least my intermediate goal. So I'm going to say sine of beta equals negative 6 over radical 37, and cosine of beta equals negative 1 over radical 37, according to what we know about, all that unit circle stuff and SOHCAHTOA. So with sine and cosine, I am now finally ready to say what sine of 2 beta equals. This is going to be 2 times let's see, it looks like negative 6 over square root of 37 times cosine of beta, and that's negative 1 over square root of 37. So if we simplify this a little bit more, let me clear some space here. Simplify it a little more, we get, let's see, 6 times 1 is 6, times 2 is 12, so that's a positive 12 over 37. There is my answer for sine of 2 beta. Okay, now, what else can we say? Cosine of 2 beta. We can keep on using this stuff. This is good. We don't have to throw it away yet. Cosine, different color. Get things mixed up here. Cosine of 2 beta equals cosine squared of beta minus sine squared of beta. Using the values that I've circled here below, here's what that equals. Cosine is negative 1 over radical 37. Okay, and that's squared. Minus, well, sine is negative 6 over radical 37, and that's squared also. So, sorry, triangle, you've got to go. Get out of here, guys. Hope you have all that stuff written down. I still need to simplify this some more. So this is going to be equal to 1 over 37 minus 36 over 37. So what does that equal? Well, that looks like negative 35 over 37 for my cosine value. Negative 35 over 37. Okay. Let's just do a little quick double check. Make sure I didn't just mess this up really bad. 12 squared plus 35 squared. Looks good. Okay, so what I just did there to double check myself, and this is very useful for you. I'm going to show you how to know if you got it right or wrong. There's an identity, which is going to come in very handy here, which is cosine of some angle plus sine of some angle equals, drum roll, right? We know this, 1. Okay, it's a Pythagorean identity. So what I just did to double check myself, and this is very, very important, is I said, hey, is negative 35 over 37 squared plus 12 over 37 squared, is it equal to 1? Okay, that's how we know if we're on the right track, and it is. So I'm feeling pretty good about this. Now tangent, for tangent, this one should be quick. Let's choose orange. Remember that tangent equals sine over cosine? So we have a little shortcut here. I know sine and cosine are right. Therefore, I can just say this is going to be 12 over negative 35. Okay, I just divided one fraction by the other, a little keep flip change, and we're done.